Hi everyone, this is Sunny Kumar from Mathematics and Computing Part 2 from IIT BHU, and I am back again with another question of Daily Leetcode Explore day 31 of January. Okay, and the problem name is next permutation. Okay, now in this question we have to basically implement next permutation. That is, we have been given an array and we have to find what will be the next permutation of this array, and there is a constraint. Sorry, there is not a constraint. There is a information that we should follow for our learning. That is, the replacement must be in place and use only constant extra memory. Okay, and we have to also notice another condition, that is, if such an arrangement is not possible, it must rearrange is it as the lowest possible order. That is, if the given array is sorted in non increasing order like this 3 to 1, then I have to output the our answer as the array in non decreasing order, that is increasing order. So how we can approach this question, how we are going to do this, let's understand this mathematically. Suppose, let me first clear the concept of next permutation. Okay, now suppose we have an array of like this 1 2 3 4. So our next permutation of this array would be 1 2, and 3 4 will get swapped and it would become 4 3. And similarly, next permutation of this, again this array would be what, 1 2, 1 2, or simply it would be 1 2 1 3, and remaining it would become 1 3 2 4. I think it's correct. Okay, it doesn't matter here. So basically we have to understand this, that next permutation of this would become 1 2 4 3. And now suppose we have an array here 4 3 2 1. So in this case you can notice that all the elements are already in non increasing order, that is decreasing order. So next permutation of this is not available, so we have to output this in increasing order. So one thing we can observe here, that you can notice all the elements are in increasing fashion, starting from rightmost element of the array to the leftmost element of the array. And if at certain index I this does not hold, that is, if at certain index I, array of I is less than array of I plus 1, we can say that there is a next permutation holding just because of this index. Oh, okay, let me, you need not to worry about, I'm going to explain it very well. Okay, suppose here we have an array 2 5 4 3 1. Okay, now one thing you can notice, that starting from rightmost element, all the elements are increasing in this order. So the first index I, let me write, find the maximum index I such that array of I is strictly less than array of I plus 1. Here I guess, sorry, here lies that we can have a next permutation. Okay, now you can see, if this is this element 2 is less than 5, then we can say that there is a next permutation we can make with this element 2. How we are going to make this is, find the elements, find the index just after the, just greater than the index I. Note that our current index I is 0, that is holding the element 2, and so we are going to find the find the index which is greater than, at more than the index I, and which is just greater than the value of I. So I'm going to write here that, sorry, find index j now such that j is greater than I and array of j is strictly greater than array of I. No, note that you can have 3, 4 and 5 which is greater than 2, but for the lexicographically minimum permutation we have to make as given in the question. you can see we have to build the lexicographically next permutation. We have to build the smallest next permutation. So the best choice is to pick up 3 and swap it with 2. So the main question that arises in our mind, that is, why not to pick up 1? So if we pick up 1 and swap it with 2, you can notice that 1 comes at the starting index, that is 1 comes at 0. So suppose let me swap it with 1. So our new array would be like 1 5 4 3 1, sorry, 3 2. So you can notice that here, 1 minute, you can notice easily that 1 is less than 2. So it is obvious that this permutation must have come before this permutation, but so according to the question we have to build the next permutation of this. So 1 is not valid here. So we have to swap, sorry, I'm going to erase this, and as it is no more useful. So we have to swap 2 with the smallest element which is just greater than the current index, current element at index I, and index j must be greater than index I. That is, we have to find j which is greater than I, and array of j must be greater than array of I, and we have to find array of j as minimum. Okay, so the suitable choice is to swap it with 3. So our new array would be 3 5 4 and 2 and 1. So now 3 5 4 2 and 1. Now you can notice that just after the index I, for the next permutation, what we are going to do now is we are going to sort these elements in increasing order, that is in non-decreasing order, because some elements might be same. So we are going to sort this in non-decreasing order. So if we sort this in non-decreasing order, our array would be like 3 1 and 2 and 4 and 5. So our answer is actually this next permutation of the, sorry, there is a typing mistake, given array. So this is our the next permutation of the array. Note that what I am doing is I am going to pick up the smallest element at index j such that j is greater than I and array of j is greater than array of I. The smallest element which is greater than array of I, and what we are going to do is we are going to swap the elements at these positions. And one more thing I am going to do is, after doing this, let me write here one more thing for the clarity, for understanding of yours. So now the sort all the elements after the index I in non-decreasing order. Why I am going to sort this in non-decreasing order? Because note that you have to find the lexicographically next permutation of the numbers. So next permutation is going to be holded by the first index, which is less than its next index, that is a of I less than ai plus 1, and we are going to swap it with that element that is strictly greater than array of I. And what we are going to do is, after swapping that, we are going to sort all the elements that are at indexes more than I, so in non-decreasing order. So that will give us the minimum next permutation, sorry, the next permutation of the given array, that is, you can see here. So this is the basically the logic behind this question, and this is very simple, so you need not to worry about. So let me move on to the code. So okay, initially I have taken the n nums dot size, which is the size of the array. Now one thing you can notice, what I am doing is find the maximum index I such that the element at index I plus 1 is greater than the element at index I. So as you can see, 5 is greater than 2. So our next permutation we can make next permutation from index I, which is less than ai plus 1. Also element and index I needs to be exchanged with the suitable element. So what will be the suitable element? Suitable element is the element which is just greater than the element at index I, and we have to find that j which is j must be greater than I. You have to notice that also. Now we have to swap the element and sort the element after the index I. This is the main logic behind this question. So what I'm going to do is I'm going to take an iterator, which is actually a variable I. I'm going to take it as -1. This is because if suppose all the elements are already in non-decreasing order, sorry, non-increasing order, that is here you see. Suppose all the elements are already in non-increasing order. So in this case, this function will not work in efficiently, because the break function does not the break we will not encounter break statement. So what will happen is I will remain as -1. So we have to sort the nums from I plus 1 to the nums of int. So it will entirely sort the original array in non-decreasing order. So now you can see what I am going to do is I am going to pick up this function, sorry, I am going to work on this function, that is find that I which is strictly less than its next index element, that is nums of j is less than nums of j plus 1. Then we can say, we can claim that we have found an I such that we can obtain our next permutation, which will be our answer. So j will so here we have obtained j. I will going to store that j, and we have to break it, and we have to move out of the for loop. Now what I'm going to do is, I guess I have written this statement two times. Okay, so you need not to worry about. Okay, now okay, you can see. Okay, now so okay. Now you can see I have found that I, and what I am going to do is find that element j which is just greater than the I, that is 3 just greater than 2 is 3. So what I am going to do is I am going to iterate from n minus 1, and I am going to take care that j must be greater than I, and I must be positive, because in the case where all the elements of the array are non-increasing order, so I would be negative. So if we fetch the negative index, it will give us runtime error. So I will take care that I must be positive, and we will start from n minus 1. And now we can notice that if nums of j is just greater than nums of I, so we can claim that I have found that index which needs to be swapped, sorry, I have found that element which needs to be swapped with the element at index I. So I'm going to swap that element with index I, and I'm going to break our for loop. So, and what I'm going to do is the we have placed the elements at right position. So our, sorry, what I have done here, it doesn't matter. Okay, so what I'm going to do is I'm going to replace, I'm going to sort that next elements starting from uh, index I, that is from I plus 1 to the end of the array. I'm going to sort all the elements in non-decreasing order, which will give us our the next permutation. Okay, so the question is very simple. So if you have any doubts, please do not forget to mention in the comment section of the video, and I will ask the viewers to like this video, share this video, and do subscribe to my YouTube channel for latest updates. Thank you for watching this video.